So I'm
Farid.
Abdullah, and we have Farid as well, and we're going to be presenting today our proposal for this project, Thus Spoke Tweety, essentially creating a truth index for Twitter profiles using deep Bayesian network classification. So the topics we'll be talking over today is just the problem statement and the objectives of our project, and then we'll go into the details of how exactly we plan to achieve this. So, like I said, we'll be assigning a truth index to Twitter accounts, and so this stems from the problem of fake news. So what exactly is fake news? It's a problem that we see rampant in our society and all over social media at the moment. And so it's important to define it, and it can be defined as a story that's made up with an intention to deceive for some sort of gain, often for some sort of monetary gain. It's often used as propaganda and often will hide among the news that we see legitimate news. And so it can be very easy to miss and thus achieves mass deception. And so some examples that we see of that are a hoax in 2018 where it was a hoax on the internet that Starbucks was giving away free coffee to undocumented immigrants. And then more recently, we can see across the internet a massive misinformation about the COVID-19 coronavirus situation, whether that be in the form of statistics or just generally wrong information about how it spread. And we see this across various platforms. And so often there are sites dedicated to spreading this sort of fake content, and often it has a political slant to it, and then it's posted on social media where it can be easily shared and blend in with the rest of the authentic news that's out there. So there's some fundamental points to note about what that we see in fake content. And one is that there is no standard solution that we can see to the problem. You can only approximate what might be fake news, since it's so hard to define and it blends in so well and often is designed to look as real as possible. And so the reason why it spreads so easily is because often it's seen again and again, and this repeated exposure just makes users used to seeing this and just accept it as truth. And it often manipulates human nature, playing on emotions and maybe just slightly deviating from what they may consider to be true information, but enough that it can make a difference. So our objectives for this project will be to understand the science and mechanism of how fake news is spread and what kind of content that it actually consists of, and then design a deep Bayesian network to attempt to detect it as best as we can. Once we have a working model, we can apply it to something like Twitter, where we can apply and generate truth indexes for perhaps tweets or profiles to try and judge how likely or how much fake news can be found in one of these. And so we plan to use to research the symbolic logic used in this model, and hopefully gain some results that we can improve the performance with, and proceed from there.
All right, thank you, Abdul. Um, the reason we're trying to use Bayesian network and Bayesian inference technique is for twofold purposes. First off, it's Bayesian network essentially came from statistical background, and it has found multiple broad-based application for classification and regression problems. Just like it states, it's a supervised learning, so it tends to use training model that um, has labels. And the essential feature of Bayesian is that it uses prior learned knowledge. So whatever that you train it on, it uses all of that information to make predictions on the unknown or unwarranted data. One of the essential things about Bayesian model is that it's very easy to train on. It's the architecture is much more linear based, and it gives very quick and very good results so far what we have seen. And the first equation, as we see, is the fundamental definition of what Bayesian really is. So if a simple example we can use is, for example, that if you would like to go outside and play tennis, so it's going to depend on multiple different attributes or features. So, for example, whether the temperature or humidity or the crowd-based or things of that nature, and it takes all of that information and makes probability tables given whatever the conditions are, and it makes a conclusion on that. So if you see the equation on the, so if you see the part on the left side is known as the posterior probability, which we will try to calculate. So in this, if C is what are the content that we are trying to look for, W is going to represent the label that it has. And on the right side, we see the PC, which represents the prior probability, which is basically whatever it has learned, given that label. And the PWC is the likelihood probability, which basically represents that given the evidence, what is the probability that the hypothesis will be true. And on the bottom, the BW represents the evidence or the prediction posterior probability, which simply can be defined as the probability of the hypothesis given the observed evidence. And this such model is then used to make predictions whether the content is true or not. So, and essentially in our fake news problem, we're going to be training, we're going to get a data set, public-based data set, which will have labels, and that will then train on it. And then the Bayesian model simply puts probability on each word that occurs given a certain label. And if it sees those words occurring in the same sequence of some kind, it's most probably going to give the label that it has learned from it. Second, very important part of what makes Bayesian really important is something called the independent assumption, which is simply that each and every word or feature still carries an independent value, which does not overlap or affect when other or multiple other features are present. And so the Bayesian network is an extension of the Bayesian inference model. So instead of just using singular based or a linear based neural net, we are going to implement it on multiple different scales or multiple different layers of neural net. And this would be much more of interest because there is still not much literature on the application of deep belief or deep Bayesian network with respect to fake news problem, because most of the times the inference models have been used as singular based. So we are still working out the complete architecture, but from a very high level perspective, what we have is that there will be a user that will be able to interact or link with a URL link, which was simply is going to be a singular page or a web page in which there will be a search bar, and the user can then be able to place in a Twitter handle or even a single tweet, which it would like to confirm and see whether if it's true or not. And on the second side, we would like to implement a method that can allow you to check the Twitter content of any user. So basically, you can take a Twitter handle of a particular user and be able to place it in. Then it is going to convert that is going to go through all of your tweets and going to make it into a metadata, which will be fed into the backend part, which is where the classifier will be running. And once it gains all of that information, is going to make a conclusion on it, whether how true the user Twitter content really is. And also, this can be similarly applied on a much more micro level, which is to take only a single tweet and be able to give an answer whether it's going to be true or not. And thirdly, which is very important, is that many of the times when you go on Twitter sites or whenever you're looking at it, it does not give you a kind of an index or a matrix or a metric to measure how true the value or how true the user really is, or how much content which it contains is actually going to be the truthful one. So that will be of very much interest because nothing of this kind has been done. And followingly, this will also carry on much more further research in the direction of fake news detection mechanism in real time. And all of this will be handled through HTTP protocol, so we can use get post methods, simple standard HTML methods to be able to implement it. So this is so far what we have seen is simply to use Python in order to build and run the deep belief network. Scrappy is simply going to be used as a web crawler in order to gain the content data and be able to make it into a metadata, which can be fed into the classifier. Postman will simply handle the backend, the HTTP protocols and things of that nature. Then you simply have a database to store our information, and HTML will be, or Django and stuff can be used as for the web page development itself. So one of the key challenges so far, what I've seen, is to actually get any good, decent, or a data set which is still been filtered out, because some of the data sets which papers or reference papers to actually use is actually kind of private, or they're not available at all. And those which are available may not be of that good, as not good quality. So it's very important, and it's still a search to find a good Twitter dataset model. DBN architecture itself is going to be a work in progress, because nothing of this type is publicly that much available, and they're not situated as to build for fake news detection mechanism. So that will be of very much interest. And lastly, I just want to emphasize on the symbolic logic, which is simply this is a new direction that is being taken in terms of Bayesian inference architecture. So far, the Bayesian model tends to have the supervised learning mechanism. But a symbolic logic is simply to use the first order logic, which is essentially used in our own reasoning mechanism of human beings. So, for example, if you say that men are mortal, so therefore I am a man, so therefore I will be immortal. Using those kind of reasoning is still, this is a much more research theoretical direction, and it would be of interest to see what we can find further on it, and how can it really apply to our own classifier, as this will allow you to give you more generative and much more better results in terms of inference from any form of data. And there will be certain problems that will be faced along the way, which we be able to troubleshoot. And so our final idea is to use a methodological and a robust model that can be applied in terms of DBN and how it can tackle and solve the problem of fake news. And further, we would like to gain some good experimental results that can be applicable and publishable for, especially for an IEEE conference paper. And that's what our main goal set for this project really is. And these are the particular references that we used, which are also available. All right, thank you.
Thank you.